All right, now since everyone just is asking for an encore, won't stop bugging me about continuing, we'll go ahead and move on to about stack frames.
It wasn't me. She's like, Emily.
For those of you at home, that's sarcasm.
Why does sub return beef and main return food?
Because it's funny. Isn't that hilarious? It's great. How can you not love beef? Beef food. Wait, do we have any vegetarians? Excellent. What's that?
So if we do no one cares. Oh, sorry, I was supposed to be nice.
Woo! All right.
Just change it to beat.
T is not a hexadecimal character. Right. You only get A and E, and then you got some.
I got nothing.
Yeah, usually it's dead beef is what people like to do. All right, the stack frame in this example will be very simple. Only save the stack frame pointer, the EBT, and save the return address, the EIB. All right. Hey, what does that all mean?
Can you repeat that? And I actually might know the answer to this one. I need you to repeat.
The stack frames in this example will be very simple. Only saved frame pointer, EBP, and saved return address, EIP. Well, that's not even a sentence, is it?
Yeah, what were you asking?
That wasn't even a sentence. Matt, who wrote this? No, it's not. Only saved frame pointer. That's not a sentence. What's the verb?
Those are two nouns that don't do
It saved return addresses.
Saved.
That's not a.
Verb isn't saved.
Saved.
Saved is a description of the pointer.
It should say
Saved is being
only
used
saved
as
frame.
I don't know. We are English majors.
Yes?
Oh no, that's back on English majors.
Yeah, this
English
is the
is
same.
not M.
Yes. Height.
What?
They can make us right.
That's how I feel.
Well, they'll get quality. It's just not the quality they're looking for.
Yes.
But what does that mean is that
Okay, thank you. So subcolon is the function being called. It's going to push the frame pointer onto the stack so it can save the old frame pointer, and then it's going to move the current frame pointer ESP, so we'll have our own stack. It does some things, and then it pops the EBP back from the stack so it can restore it in case we messed with it. This is kind of an example, doesn't make too much sense because those instructions weren't actually necessary, but that's the way it works. And also inside of main, it's the same thing. We save off the stack, the frame pointer, move it to our stack pointer, and then we call subtraction, which of course does the same thing again. And then when it returns, we get the result from a sub, which is stored inside of EAX, because by convention, functions, when they return something, are going to store it in EAX. And we're going to, actually, hold on, I take that back. It returns beef, but we completely ignore it, and then we're going to return inside of main, because notice that in here in main, we get beef, but we ignore it, instead return food. So our function in main is going to return food, and so we pop EBT and then we call ret. All right, that was beautiful. So let's see how this works. Well, on the left we have our code as well as the memory addresses of those code. Remember, our programs exist inside of memory. So on the left column here are the memory addresses of our code. And over here, I don't know what that address is for yet. That's our stack. We'll just say our frame starts right here, and we're going to push belongs to the frame before the main call. And so when we're going to push on the frame where we're calling, before we call our function, before main is called, i.e. the operating system does this for us, it pushes the address of E8. Where is E8? 4012. It's not even in here. Well, that's the address of the operating system saying when you're done, you need to return to this so the OS can take care of it. That's what's actually going on. Ooh, almost zoned out there for a moment. All right. So that's the operating system. This is where you go when your program is done. It transfers control to here. So it's going to push the EBT, which is, we'll say that's where our frame is pointing to now. And then we're going to set it to the ESP so that our extended stack pointer is pointing to where we are in the frame. Notice that this is simply pointing back to the beginning of the frame. Over here, where my mouse pointer was, are the registers inside the processor. Notice also we've highlighted the move, which is going to ESP. Now we're going to call subtract. Since we're going to call, we're going to first push the address of our function. It should be, I'm not address of our function, I'm sorry. We're going to first push the instruction after the call. So this address 401018 is the address of the next instruction when we return from the call. You can tell that this address is right here, which is the move instruction after the call. Then it's going to jump up to sub because that's what call does. And push sub is going to push the EBT. Well, what is EBP? Wow, EBP. That's our old stack pointer, so we're going to save it off, aka that one. And then we're going to update. And then we're going to update, or we're going to move on in life. Oh, we're going to explain this in more detail. Sure. So, what's going on here? Well, from the green up is the function before main's frame, i.e. this is the operating system. Don't mess with the operating system. Main's frame is right here because that is what was stored on main. Obviously, there's only two things, not much was being stored, but there were two things being stored for main. Then sub's frame is right here, and that's what's being stored inside of sub. Notice that main, as he said, it had to be the frame pointer of where the previous frame pointer was, and then, what was it, this one is the return address when sub returns so it knows where to go. All right, so then we're going to move beef into EAX, and then when we pop EBT, we're actually going to take, let me back up one instruction, so we're back to EAX. Notice the top of the stack is 12FF86 or 68, AK up here. We'll pop EBP to restore it, and then when we return, we're going to pop the next value and then jump to that instruction. So we pop the next instruction during RET, and it jumps us down to the move instruction that we're here, and the EBP has been restored as well as the ESP as well. Then we can go ahead and update EAX, and we're going to pop EBP, aka take the old value that was EBP before our function was executed, restore its value, and then when we call return, it's going to take the instruction address that we were supposed to go to and jump to it. All right, everybody got that?
I heard the words.
Every time your program runs or your function is called, something like this happens. So when people refer to function overhead or the overhead to calling a function, that's what they're talking about. And of course, the stack grows and shrinks per every function call, and you might have some extra data on there as well. Okay. You will probably need to watch that video again.
We need to watch
Especially when we get to recursion.
it. We got manually programmed recursion.
Yeah.
Alright. Yep.
I'm not going to do, well, I don't plan on doing complicated recursion. Single tail recursion, not quick sort or something like that. We won't do that. Or I don't plan to. Unless you want to.
No.
I'm
You
good.
sure?
No.
We can do it. I mean, it'd be fun. I'd like it. No?
Thank you.
I will throw something at you.
I feel like you
Will it be soft or hard?
Is that even a question?
Yes. Is it your hydro flask or something else?
Crunchies?
Maybe some scrunchies instead? Just no Crocs, okay?
You do an entire class on assembly. Like, you could just.
Oh, yeah. Oh, easily.
Class.
Well, the cool thing about this is I could do a reverse engineering course where you take a binary and then reverse engineer it to the and figure out what it does, aka figure out what the source code was doing.
So, like, can you modify it though, or is it
Yeah.
like so for academic purposes, if you wanted to look at a piece of existing software out there.
Yeah, and then modify it? Yeah. Well, no, that's perfectly legal to do.
I mean, yeah.
It's not modifying yourself, it's perfectly. Oh, you mean for games and people modify?
I
it so
mean,
they
I'm
get-
not saying that. Just
Well, yeah, how do you think they did it?
I know.
They just can't sell it. 'Cause that's
See,
It depends.
that's where you get into
that is very it depends.
the thing itself, because it's
Because the program itself, reverse engineering, is protected by federal law. So as long as you never had access to, or no, I'm sorry, let me rephrase that. As long as you never had illegal access to source code, you are allowed to build whatever reverse engineering tools you have, unless there was something explicitly stated in the license when you bought the code. Most of the time, even if it was stated in the license, as long as you reverse engineer it the correct way, the federal courts will back you up. But it may cost you a lot of money because you still have to fight with lawyers. So, I know, hopefully that wasn't too complicated of an answer.
I believe the legality issue is when you basically you're infringing on their copyright because you're distributing their
So,
software legally.
like for example,
cracking
if
their
you're cracking a software and your software includes their logo, that's illegal because the logo is copyrighted material.
Yeah.
But if you distribute your source and it doesn't have the logo or anything from it, it just is labeled something, and you can even like trademark the name, and that's okay. Or even if you just don't include the name, you just say it's my hack, and that's all you call it.
Or is your hack itself not illegal, but the person who then uses it
Nope.
to bypass the thing
That
to
depends on
get
how they.
access for free is
That
what I
depends
mean.
on how they use it.
Ah. Gotcha. Interesting. Anyways.
All right. Anyways. So the sub function is dead code. Its return value is not used for anything. If you go back to the C code, let's not go back to the C code. Let's go to the C code. Maybe we'll go to the C code. There, C code. Sub is just returning beef, but we don't use beef. Well, we use it here. This is a different function than what was done in the slides.
Where's the sub? I don't even know what sub is.
In sub, right here.
I don't see- Oh. Oh, okay.
The
Sorry.
the sub has beef in it.
It confused me because it was just one line. Okay, I'm good.
All right, let's do it in a tool. Well, hopefully you followed that in class code and we can look at it. I'm trying to get a hold of IDA so we can actually see how the disassembly tool works. All right, let's go through another example. We just went through this example. All right, input parameters with local variables. How are we doing? Good, we have enough time for this.